So we have covered the following 12 list methods, and what I would like to do is explore them and play around with all of them inside the interactive shell. And I'm going to talk you through every operation and what it is that it's doing. I will also venture a little bit past just these functions to sort of show you a common error that happens with lists. So let's get started. Python console, this is going to open up the interactive shell. And what we're going to do is we're just going to enter numbers and letters so that they're saved in here. And now I'll do the append first, and then I'm going to do the copy, and I'll show you why. So let's say we want to append a number to numbers. It is going to say numbers.append, and then you enter a value, and you check the new value of numbers, and it's 9. Now, let's say you want to use an equal sign to create another list like numbers. Now, this is actually not going to create another list. Let's say we have n, and n equals to numbers. Now, if you numbers.append 10, the new value of numbers is going to have 10, but the new value of n is also going to have 10. So the equal sign basically only has the n variable point to that original list that we created. If you want to create a copy, this is what this copy method is good for. So let's say you have n2 equals to numbers.copy. Now, let's append something to numbers again. Numbers.append. Let's just put a second 10, just for the fun of it. Numbers.append 10. So now that we look at numbers, come on, Sonny, type better. Numbers. You notice that there's these two 10s, but remember, n2 is numbers.copy. N is pointing to the numbers. So, entering n, that second 10 is there, but n2, which made a separate copy of numbers, does not have that second 10. So if you want to copy a list, that's what you use the copy method for, and that's why you should avoid using the sort of assignment operator. So this is going to get you into trouble with lists. Okay, let's have a look at extend. So we have numbers, and if we said extend as opposed to append, now extend uses an iterable. This can be a string, it can be another list. So let's say we append just a little string, my name. If you type in numbers, look at that. So it actually appends each character as an item. You could have done something like this, append letters. And now numbers is including actual list, A, B, C, D, as a whole appended item. So that's interesting. Now what I'm going to do is actually clear, because numbers is too big. So if you type in numbers.clear, the new value of numbers is an empty list. So let's go back and create numbers to what it was. I think I can just scroll that. That's been a bit of a reset. So we've covered copy, clear, append, extend. Time to insert something. So let's say you want to insert something at the front. So it'll be numbers.insert, index 0, I don't know. Let's say you want to insert number 0. So the new numbers are going to start counting from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. You could have inserted something into the middle of the list. So what that would look like is you pick an index, say 4, and then in the 5th place, you would have inserted, just to make it interesting, let's make it X. 1, 2, 3. So that's 4, that's the 5th place. 0, 1, 2, 3. So 1, 2, 3, 4, 5. Or 0, 1, 2, 3, 4. Index 4. Aha, remove. So since this X is kind of in the way, you can numbers.remove X. And now X is gone. Next, we can pop an item, and now we can use it with and without an index. So let's say A equals to numbers dot. So A is equal to the very last number. But not only is A equal to that, numbers now no longer has that item, the item which has been assigned to A. But you can also pop any particular item. You can pop from an index, so to speak. So numbers dot pop. Let's say we want to pop number 1. That's actually going to be at index 1 now. And let's assign it to B. B equals to. So B is 1. And it's going to go, numbers is now going to skip 1 and go 0 to 2. Okay, list.clear. We have covered list.index. Now, let's go to letters, because we haven't really done much with them. Letters.index C. That's going to return the place where C is, 0, 1, 2. Now, what would happen if we were to use that search index, the start and end? Now, let's have some fun with letters. Like, let's make it big. Letters equals to letters times 3. So, if we look at letters here, there are multiple places where you're going to find the C, multiple places where you're going to find the D. So, in fact, every letter occurs 3 different times. So, let's just say we are looking for where does C occur at the end of the list. We can do that. So, just one more experiment. Letters dot index C. Now, unsurprisingly, this returns 2, and that's 0, 1, 2. That's the first occurrence. Now let's look for that last occurrence. So the length of this list is 3 times 4 is 12. So we are going to look for C, letters dot index. We're looking for C in between index 8, which is the 9th item, and index 11, which is the 12th item. Boom. There it is. 10th place. Index 10. Index 11 is the very last one. So, what else do we have? Index count. Well, let's say you have numbers, and you can numbers.count. Well, if we say 7, that'll return 1, because 7 appears once. But now letters, we can have some fun with that. Letters.count C. That should return 3, because C appears 3 times. And letters dot count A, B, C, D. Aha, there is no E, so if we were to count E, that should return 0. So next we have sort. So if we were to sort letters, then these would be sorted in ascending order. A, B, 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 C, 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 D, D, D. The same would happen with numbers. If we were to reverse it, well, the list would be reversed. So letters dot reverse. Now the list itself changes when you do these list functions. If you type in letters now, letters has been reversed. So just to recap, in this video we had a hands-on interactive shell experience with list methods. We've covered append, extend, insert, remove, pop, clear, index, count, sort, reverse, and copy. Now before we wrap up with lists, I want to cover list comprehensions. Now list comprehensions are a special Python feature which makes it really easy to make lists. Probably the most concise way I have seen making lists in Python. Now the way this works is you've got 3 elements. The first is an operation that you're going to apply to items that come in an iterable. The items are being fed in by a for loop, and you have the ability to check if statements. So, for example, you can feed in numbers 1 to 10, do a particular operation on them, and then check if the result of that operation meets certain criteria. And if it does, only then are items basically fed into this new list. I know it seems complex, but let's have a look at them in code. They're not so difficult. So in this video, we are going to take a look at list comprehensions. And I know that the theory might have sounded somewhat strange and esoteric, but the format of this is really simple. What you have is a variable name equals to square brackets in which you have operation, for loop, and an if statement. Now the if statement is optional. And how this can look, let's take an example. So let's say we have squares. Now we are going to square all the numbers 1 to 10. So first of all, we define the operation. So you can use a variable name here, num squared. And now you can iterate num, the for loop, for num in range. We're going to start from 1 and go to 10, which means the upper bound is 11. So if I just print squares, then you're going to see, there it is, we've just generated a list of squares from 1 to 10. Now, let's play around with this if statement. So let's say we want to get odd squares and even squares and have them in a separate list. So we're going to have odd squares and we're going to have even squares. Now this is going to depend upon this condition out here. And let's define that condition. So if for each num you're going to square it in here, you can actually check if this num meets a certain condition. If the square of the num is perhaps can be divided by 2 with no remainder, divided by 2 is going to not be equal to 0. So not equal to 0. So let's check this. We have operation, range of num, condition. If that is true, then you're going to run it. We'll find out in a second if that worked out. So odd squares. Run it. Yep, 1925 exactly. So these are the odd squares. So the even squares are going to have the same condition, except in this case, the condition is actually equal to 0. So print even squares. So there you have it. This is an example of list comprehensions.